So let's okay. So let's discuss this problem. The problem name is longest consecutive sequence, and let's read the statement. Given an unsorted array of integer nums, return the length of the longest consecutive elements of sequence. You must write an algorithm that runs in of n time complexity. So, so we have a array, and we have to find the longest consecutive uh, sequence. Longest consecutive sequence, like the difference of consecutive elements is 1, and we have to find the length of longest possible sequence, right? The main constraint is here is that the algorithm should run in of n time complexity. That means we cannot sort the array, because the while sorting the array it takes n log n time, but the question asks to solve this in of n time complexity, right? So let's take an example here. 10, 4, 200, 1, 3 and 2. So the longest consecutive sequence is 1, 2, 3 and 4, right? And taking this example, the longest consecutive sequence is 0, 1, 2, 3, 4, 5, 6, 7, 8. So my longest consecutive sequence is 9, right? So how can we solve this in of and time complex? Let's take sample test case 100, 4, 200, 1, 3, 2, right? This is my sample test case, right? And I used unordered set. I used my unordered set for storing the elements. The time complexity for inserting and accessing the element in unordered set is of 1. Right? So I put all these elements in this set. Right? Now I am traversing. Now I am traversing the array. I get 100. Right? So 100. I reached at 100, and I'm checking that 100 minus 1 is present in my array or not. Is present in my array or not. If my 100 minus 1 99 is present, then I did not need to take 100 as my starting element, because we know that 99 is present. Of course 99 should be my starting element, but if 99 is not present in my array set, that means 100 can be my starting element of the sequence, right? So 100 can be my starting element of sequence. So I check for 100 plus 1. If 100 plus 1 is found, then I check for 100 plus 2, and so on, and so on, right? But if 99 is present, then I didn't need to check this sequence, because 100 is not my starting element. 99 is my starting element. So whenever I encounter 99, then I take it as my starting element and check for 99, 100, 101, and so on, right? So 400, there is only one sequence, I get 4. Now I am checking, is 4 minus 1, 3 is present or not? Yes, 3 is present. So 4 is not my starting element. Then I go to 200. Now I check that 200 minus 1, 199 is present or not? So 199 is not present in this array set. So 200 can be my starting element of the sequence. So I check for 201, 202, and so on, right? Now I get 1. No, now I get 1. Now I check 1 minus 1, 0 is present or not? 0 is not present. So 1 can be my starting element. So I check for 2. Yes, 2 is present. Then I check for 3. Yes, 3 is present. Then I check for 4. Yes, 4 is present. So the maximum length of consecutive sequence is 4, right? Now I move to third. Then I check 3 minus 1, 2 is present or not? Yes, 2 is present. So 3 can't be my starting number. Then I go for 2. Then I check 2 minus 1 is present or not? Yes, 2 minus 1 is present. Then 2 is not my starting element. So what I am doing here, I am currenting at any element, and I am currenting at any element and check for uh, that element minus 1. Check for that element minus 1. If that element is present in the array, then that element is not my starting element of sequence, right? So that element is not my starting element of sequence. Let's write a. Now I put all the elements in set. Now this is my answer. Let's check if st dot find numpy minus 1 is equals to st dot end. This line means that nums minus 1 is not present. Then what? Then nums I is my starting element of sequence. So if nums I is my starting element of sequence, then I search for nums I plus 1, nums I plus 2, nums I plus 3. So while st.find nums I plus 1 not equals to st.end length plus plus, right? Then simply do answer is equals to max of answer comma length, return answer. So this is my code. Now let's check. Okay, this give me TLE. Okay, I found nums I minus 1 is equals to st.end. That means nums I minus 1 is not present in the array. Then I do st.find nums I plus 1. Sorry, that not be nums I plus 1, that should be nums of length. Yeah. Yeah, accepted. Uh, the time complexity of this code is O of n, because because this while loop can access any element at least twice. That means I reached at 100, right? So I check 100 minus 1, 99 is not present in the array. So 100 is my starting element. I entered into the array. Let's take an example. What if my array is 1, 2, 3, 4, 5, 6, 7, right? I reached at 1 and I checking that 1 minus 1 equals to 0. 0 is not present in this array. So 1 is my starting element. 1 is my what? 1 is my starting element, and I check for 2, 3, 4, 5, 6, 7, right? This operation is done into this while loop. Like nums I is my 1 and length is 1. Then I check for nums I plus 1, 1 plus 1 2, 2 is present in the array. Then length is my increase. Then 1 plus 2, 3 is also present in the array. Length increase 1 plus 3, 4 is also present in the array. So in this way this while loop works. But this while loop is done only once. Like this while loop does not again traversing for this index, because when I reach to 2, then I check 2 minus 1 is 1. Yes, 1 is present. Then 1 is present. So this condition is false. Then I can't enter this block, and I didn't do a while loop for 2, same as for 3, same as for 5, 6, 7. So this while loop is occurs only only once. So this is of and time complexity.